Houston. Expecting cloud cover shortly.
Trip is stable.
UTEP is good. Touchdown confirmed. We're seeing
On November 26, 2011, the car-sized robotic rover Curiosity was launched from Cape Canaveral. For 112 days, the rover traveled from Earth to Mars. Yet the most terrifying phase was the 7 minutes of terror, also known as entry, descent, and landing. These 7 minutes of terror kept NASA engineers on the edges of their seats, desperately listening for the signal from Mars to reach Earth and know if the rover safely touched down or smashed into Mars's rocky surface. Thankfully, Curiosity was safe and its landing successful. However, Mission Control lacked real-time terrain mapping, and we're very lucky the rover did not crash. It was decelerating from 13,200 miles per hour to 0. They had no margin of error. So how can we improve this difficult procedure? ASE developed a 3D flash light detection and ranging video camera, also known as LIDAR, to create a real-time map of the obstacles surrounding it. This map is topographical and also shows how much distance each object is from the camera. In 3D flash LIDAR, the mechanism emits short pulses of radiation from a laser, much like bats emitting sound waves for echolocation. The waves travel as far as they can until they hit an object and reflect back to the camera. It then measures the time it takes for the wave to return and calculates that time into a distance. For example, if the camera was programmed to shoot out lasers at 30 miles per second and the laser returned in 2 seconds, then the distance traveled was 60 miles. So, the distance between the camera and the object is 30 miles. By generating a graph of these statistics, it can quickly generate a 3D map for any use. Currently, 3D flash LiDAR is used for docking at the International Space Station. Missions include SpaceX's CRS-1 Dragon, which successfully arrived at the ISS for berthing. And just this past May, ASE's cameras were selected for use on the Origin Spectral Interpretation Resource Identification Security Regolith Explorer mission, also known as OSIRIS-REx. It will be the first mission to carry asteroid samples back to Earth and will launch in 2016. However, in the future, NASA hopes to use this technology to develop a system that can make landings safer and more accurate. So how can the Spinoff help people on Earth? First off, the cameras can detect nearby objects, such as cars or people, which a driver may not be able to see. This would prevent accidents and crashes that kill thousands of people every year. By providing a map of all the objects in the range of the camera, the user knows to avoid these objects and avoid a collision with them. The cameras can also be used for flying vehicles, such as airplanes or helicopters. LiDAR can help pilots see through smoke, dust, fog, or other hazardous conditions that limit the pilot's vision. This would also prevent unnecessary damages to both the vehicle and the passengers. This technology can save lives.